we are going to be looking at doing today's assignment, determining gravity. You can find this on the Moodle site. So physical science, if you go on down to the force, momentum, and energy section, and determining gravity should be the third or fourth one from the top. And so in this case, our setup is this. A group of scientists studying gravity are attempting to determine how factors such as mass and distance of force affect the force of gravity. So, is that when we talk about the gravity of an object, we've discussed how that near the surface of the Earth, the acceleration due to gravity is 9.8 meters per second squared. But if we were on the moon, that acceleration due to gravity would be less, and the force of gravity would be less because of the fact the moon has a different mass than the Earth. We also know that different objects have different forces of gravity. Things that are more massive on Earth typically will have a greater gravitational force, and things that are less massive will have smaller gravitational forces. The other thing that plays a difference in the force of gravity is going to be the distance between two objects. Obviously, it's the case that even though the sun is much, much bigger than the Earth, much, much more massive, is that we don't notice the force of gravity from the sun here on Earth as strongly as we notice the force of gravity from the Earth, and that's because the sun is much, much farther apart. And so for the purposes of doing this lab, we're going to try to identify what are the factors which affect the force of gravity and try to come up with an equation. And so this sort of data that this groups of scientists have come up with, that we have in our, that we'll see in a second here, we're going to use Excel to analyze that data to try to find an overall equation for the force of gravity. So the first thing you want to do is, you'll see there's a link right here. Download and open the data table with all the scientist data here, determining gravity. And so if we click on that, we'd open one up. I've already got it open, so I'll move over to that. And so it's going to look a little bit like this section right over here. So you'll see that there's a series of tabs that are down at the bottom, and we're going to be moving those tabs in a second. Things that have green boxes are basically places where you're going to need to put in an answer. These are the parts for which will be graded. So to start this off, let's go ahead, and if you look at these tabs down here at the bottom, you're going to go all the way over, click the left arrow until you get to mass m1 versus gravitational force. Go ahead and click on that. So what we have here is basically data where the scientists have recorded the mass of one object, and we're going to call that m1, the little 1 indicating that this is the mass of our first object. And so we go from 1 kilogram up to 5 kilograms, and they measure the gravitational force. So an object with a mass of 1 kilogram has a gravitational force of 9.85 for some given distance and some given planet mass. And so then something that has a mass of 2 is 19.63, something with a mass of 3 kilograms is 29.51 newtons, and so on and so forth. What we're going to do is we're going to graph these data and try to find an equation that will relate these. And so to graph them, you're going to basically highlight this whole section. Make sure you highlight all the numbers, and probably the header too, mass m1 in kilograms and gravitational force. In order to actually graph this, you're going to go up, and you're not going to be able to see the menu here because I cut it off accidentally, but you're going to go up to Insert in your menu, and when you do that, you'll see there's a chart. So hit Insert Chart. It's going to bring up all sorts of options. In fact, you'll probably see this to start with. You're going to want to switch over to an XY scatter. By doing that, to do that, you're going to click on this arrow over here, and you'll see XY scatter as an option. And then you're going to click this first one. This is Marked Scatter right up here. So it just has some dots. And now we have a graph showing gravitational force, which is on our y-axis, and mass in kilograms on our x-axis. And so anywhere that we basically see y in an equation, this would be the force, F. Any place that we basically see x, this would be the mass, which we said was m1 right up here. Now, over here, we have our next step. It says, based on this function, how should m1, the mass of the object, show up in the equation of gravitational force? The question is, what function? Well, to find the function, we're going to use a trend line. So you'll hold down Control on your keyboard and click on one of the dots. So you have to hold down Control while you're doing this. You'll go down to Add Trend Line, and that'll pull up a little dialog box. You're going to select the power. If you're not in this category right now, if it starts off up here, you'll click Type first, and then click on Power. Then go over to Options, and click the button that says Display Equation on Chart. Hit OK. You'll notice there's a little equation that's down here. says y is equal to 9.843, x to the 0.985. We can sort of zoom in on that if I can. Well, let me zoom in. I can probably do a little bit of zooming here just to see what this looks like. And so I'm going to zoom in 200% just for a second on this. And when you do that, you'll notice that see how the equation is. So y equals 9.843, x to the 0.9985. And that's what this would look like right here. So that's the equation we're going to start off with. Once we have that equation, we're going to want to try to interpret it here. Now, over here, you can see I've written that same equation, 9.843 times x to the 0.9985. In order to basically get the equation that we want for this, and that's going to be our f, see it says f equals over here, we're going to have to interpret this. Now, the first thing is we don't want to include our coefficient. So this coefficient that's the 9.843, we're not going to include that in here. We're just going to have it be x. And the power of x, you notice it's 0.9985. That's basically x to the first power. Well, x to the first power is just x. So we end up with f equals x as the general trend. So the next thing we want to do is we want to have this not be x, but we want to have it be what the actual axis is down here. And we said that was the mass, that was m1. And so instead of x over here, we're going to put m1 in its place. And so that's the equation that we'd want to use. And so over here, we can say f equals m1. If you really want to make it look fancy, you can just highlight the 1, and then you can use the formatting palette. If you don't see it, it would be under View, Formatting Palette, and you can do a little subscript like that if you want to make it look pretty, but you don't have to do that. You could just use m1 in its place. Once you've done and gotten this equation, you're going to go over and do the next one, the distance. You do the same thing. You're going to make a graph, find the trend line, and then interpret it the way we did over here in order to find what an equation in terms of the distance when the distance is r. You can sort of see it says distance r. And so instead of having y, we're going to have r. Instead of having x, we're going to have r. I'm sorry. Instead of having y, you'll have the force again. That's why it's F equals instead of y equals. You'll do the same thing with mass m2. Now, let's take a look and see some examples of how you might have to interpret these. We've already figured out m1, but let's look at r. Let's say, and this is just made-up data, so don't use this in your actual lab, but let's just say that y equals 34.383 times x to the 3.003. So since this is the r one here, instead of putting x, we're going to put r. Now, we don't want to use that coefficient that's out front, 34.383. We're going to leave that off. But this is x to the 3.003 power. That's basically, as a whole number, going to be the third power. So you can just put r cubed if that were the case. If this were 2.003, you'd do r squared, something like that. Another possibility is you're going to have one sort of like this, where it's actually x to the negative something. In this case, x to the negative 3.992. And so since it's negative, remember a negative power is the same as the inverse of a positive power. And so if I were going to do x to the negative third like that, or negative fourth in this case, because 3.999 rounds to 4, instead of doing x to the negative fourth, you would do 1 over x to the positive fourth. That's the easier way of doing this. So that would be the type of thing you'd get. Once again, these are examples, so these aren't the ones you're actually going to come up with, but they'll probably look something somewhat like this. Once you have all three of your equations, you'll go to the last tab called Finding G. In Finding G, it says, first, now put all of your equations together for your final equation. So let's take a look at our three equations here, the test ones that we got right here. So the first one that we got was this m1. It was just m1 by itself. So we'll put an m1 right there. And the second one we had was r cubed. So we'll do r cubed right there. The third one we got was 1 over x to the fourth. Actually, that should be m2. We forgot to change that to m2 because if you look back here, you can onto the mass m2. You can see it's mass m2 is what we used here. So over here, we'd say 1 over m2 to the fourth power. And then what you want to do is you want to multiply all these together. Well, m1 times r cubed is just, well, m1 times r cubed, right? and then times 1 over m2 to the fourth. Since it's divided by the m2 and it just times 1, this is the same as just saying this is over m2 to the fourth. And so our overall equation here would be m1 times r cubed, r cubed. You can put it in with a little arrows like that, the little up caret to show that it's a power, or you can do it sort of the way I'm doing it here, and you can use little subscripts and superscripts from your formatting palette, and that'll work just fine as well instead. And so this is the equation that we get. m1 times r cubed divided by m2 to the fourth is the equation I got. And that's what you'd go ahead and put, obviously with your numbers, not with these made up numbers, in this equation box right here. Well, once you've got that, that's your overall equation. But there's one other thing we need to have. It says this equation is not yet complete. There's an additional constant that's called g, which is the number out front that we've been ignoring so far. You know, we've always left off these coefficients. Well, now we're going to try to figure out what the coefficient is for all of them, not just for m1 or r or m2, but for this whole equation we came up with here. So g is a number which is multiplied times the variables that are on the right side of the equation, each of these guys that's over here, in order to get the right units for force. We want the force to be in newtons. But if we just put the numbers in here with the masses and the distances we have, it wouldn't come out in newtons. So we're going to have to multiply it by this number g, capital G, in order to find this out. And the way we're going to do that is by taking each of these values of m1, m2, and r and plugging them into our equation. And so what you do is you would say, all right, well, if my equation is m1 times r cubed divided by m2 to the fourth, then what I would want to do is go ahead and say, all right, so the force is going to be equal to, and you put this in your calculator, you'd say m1. Well, what's my first m1? Well, it's just 1. All right, so I'll put in a 1 right there. And then times, the next one is r cubed. Well, r looks like it is about 5 million right here. And so I would say 5 million, 2, 3, 1, 2, 3. Since it's cubed, we'll put cubed up here. And so you'll put that in your calculator. And then divided by m2 to the fourth. m2 is a really big number. It's 6.00 times 10 to the 24th. Remember that you can put this into your calculator as a scientific notation. In most cases, by using the E or double E key. Some of you have EXP on your calculators instead. But you'll say 6.00 times 10, or e to the 24th. In this case right here, we set it to the fourth power. So you have to raise that to the fourth power. And well, if you put it in your calculator, and I'll go and run this calculation really quickly here. So let's take a look at using this with the calculator that's on the computer. We'd say 1, clear this out first. So 1 times 5 million. 5, 1, 2, 3, 4, 5, 6, but it's to the third, so we're going to cube that right there. And so we say equals, divided by the number that's on the bottom, 6.00, and I'm actually going to put that in parentheses to be on the safe side here, 6.00, then times 10 to the 24th, so EE 24th, and then what I'm going to do is I got to take that to the fourth power, so I'll do y to the x to the fourth power, and then close my parentheses, and equals, and we've got a little bit of a problem there. So let's see if we can figure out what the problem is here. That number is probably too big for this calculator. Well, for the time, this really didn't work out very well because the numbers I made up picked a power that was a little too large. So instead of doing that, I'm going to do it on my calculator here and see if I can get this to work. So 5 million, the numbers you're going to have are going to work a little bit better than this. You won't have this little problem right here. Divided by 6 times 10 to the 24th to the fourth power. All right, and so when I do this, I end up with 9.645 times 10, using the E right here, to the negative 80th power. So it's a really, really small number. And so that number right there is the one that you would go ahead and you would put in to this spot right here. Okay? And so I'll try to leave it green if you can, so you type into it rather than copy and paste. So this is the force using your equation. And you're going to do the same thing using these three numbers and using these three numbers. Just plug them into the equation that you have right here to find the force using your equation, which is this one right here. Now, this is the force using your equation, but these numbers right here are the actual force in newtons. So this is what it really is if you did it in newtons, whereas this number is in some weird different units. So to find G, here's what we know. We know that the actual force in newtons, which in this case, I'm just going to copy this back over again. The actual force in newtons, we just figured out, it just told us for this one is 16. And so you're basically going to say that 16 equals G times the number that you got. Because G basically is the number you have to multiply your force by to get it in newtons. Once you have this, can you solve for G? Yeah. All you have to do is divide both sides by this 9.64, in this case, times 10 to the negative 80th. So you'll be able to say 16 divided by that to figure out what G is. And so in my case right here, I get that G is equal to 1.65888 times 10 to the 80th power. And so that's what I would put in this spot right here. And then you'll find G's as well for each one of these. Once you have all your values of G, you'll average them together to find an overall average, and you'll put your average in here. And then for your last step is you're going to add that G into this equation. So in the same way that we basically said G times this part right here, well, remember that this section right here just came from this original equation. And so really G is going to be the number that goes out in front of this right in this spot. And that overall equation, what you have right in here, but with the G out front, is whatever value you get for G out front is the number that you're going to put right there. And that's basically what you do. Once you finish with this, then you're going to go ahead and save it. Here's how you want to save this particular lab. If you look down at the bottom here, it says once you've answered all the questions in the data table, save the data table as determining gravity, then dash your name. Make sure that you have this .xlsx at the end. And then once you've got that, is there for your computer, you're going to see a little submit box. You're going to go ahead and submit it right here. And that's basically what we have for the lab for today. That wraps things up for today.